Hi everyone, it's Kamil, and today we are going to backtest our crypto trading strategy in Elixir. This is a 9th episode in the series dedicated towards creating a cryptocurrency trading bot in Elixir, so if you want to follow along, read the description below. Otherwise, don't forget to leave the like and subscribe if you liked it. Enjoy! In previous episodes, whenever the trader finished the trade cycle, it was stopping with the trade finished atom. As we can see, this resulted in an error being printed out, which is less than perfect. We can fix that by changing the leader and the trader to use the normal atom to indicate that the trade cycle has finished. When I was testing the code, I realized that all traders have the same ID. This happens because we are not assigning new IDs when the trader finished the trade cycle. Back to the main objective of this episode. Let's look at how the normal flow of the trade events looks like currently. Our Binance streamer is establishing a WebSocket connection with the Binance API, then starts to receive messages with trade events that it decodes and broadcasts to the trade events PubSub topic. There are two types of subscribers subscribing to this topic: traders who based on those events are making investment decisions, and subscription workers that store those events in the database. For the backtesting, as trade events are already in the database, we can just broadcast them back to the same trade events PubSub topic. This is exactly the reason for the separation using PubSub topics. The trader doesn't really care who was the producer of the trade events, as long as they are broadcasted to the agreed topic and they have agreed structure. We will introduce a publisher module inside the data warehouse application that will stream the records from the database, broadcasting them to the PubSub one after another every few milliseconds. The publisher will be a short-lived process that will be started for a single task and then it will stop. GenServer could work for this, but it would be better to use other abstraction more suited for this kind of workload. More precisely, the task behavior. You can think about it as a GenServer that at start takes a function name to run, it runs it and then it stops. We will use pattern matching on arguments inside the run function to confirm that we should broadcast the trade events. In the future, this publisher could possibly be used to broadcast different data into the PubSub, depends on the past arguments. For the convenience of usage, we will limit our database query with the time range. As trade time is stored in DB as a timestamp, we will need to convert the YMD string date passed to the function to numerical representation before using it in the query. To be able to stream the data from the database using Ecto, we will need to start a transaction and make our query inside it. The query itself is a simple select with the symbol and the trade time conditions ordered by the trade time. Using the repo stream function will allow us to work with the huge datasets without querying all the data at once. We will add an index to be able to measure the progress of our broadcasting. As we will iterate through the results, process will sleep to give the trader some time. We will log a confirmation message every 10,000 results streamed and broadcast every one to the PubSub. Normally transaction has limited runtime, so it would time out before we would be able to evaluate full result set. To fix that, we will set its timeout to infinity. The publish trade event function will convert the data warehouse trade event to the streamer trade event using the struct function as previously. Now we need only to remember about lowercasing the symbol name and we can broadcast the trade event. First, we will parse the date using the naive datetime module. We can then convert the result to the datetime in the UTC time zone. Datetime will allow us to retrieve the timestamp, which we will multiply by 1000 to get the time in the milliseconds. Very quickly, before running the backtesting, let's tidy up our code using mix format. For consistency, we'll use known dataset of trade events, which I linked to in the description below this video. We will download it into the temp directory, uncompress, and then use the psql CLI tool to load all of them to the database. As our database now holds more than 200,000 trade events, we can start the IX session and backtest our strategy. First, we need to start storing the orders. Then we need to start trading on the same symbol. Lastly, we need to run the new publisher. What you can see now is a subjective extract of about 20 minutes of backtesting. In that time, 206,000 trade events were pushed to the trader with 5 milliseconds delay between them. After broadcasting all the events to the PubSub, we can go to the database to confirm how many orders are there. Here we can see that 40 orders have been placed by the trader, as well as 206,000 trade events were in the database. Based on the orders table, we will be able to estimate how well or bad our trading strategy performs. This is a very first and vital step, and I'm really happy about it, because it gives us some indication and really showcases the trade-off that we took when we gone and spreaded all the messages using PubSub instead of directly communicating. Now we can just swap the producer in place and run our backtesting, which I believe is really cool. If you enjoyed it as much as I did, don't forget to leave the like and subscribe. See you in the next episode.